Okay, now, all right. Okay, let's wait for a little while. So for today's class, I've actually prepared for a function part, but maybe I will also give you some slight review of linear equations. Okay, before we start, let me just give you a little bit review of what we have done here. Okay, so yeah, for this part, the inequality, remember that if you have a rational like this, what you need to do, you need to make it this happen. Okay, and then you solve this, and you will see that it's actually solution D. Or you can try to solve based on uh, the solutions also. Okay. And for this one, you can see the x, y, y, and you can simplify into the complete square, and then you can complete square. This is 1 over 4, 1 over 16, 1 over 16, and you need to plus 2 over 16. Oh yeah, wait for a minute. So that's it for the radius, and you will see the radius is half, and the center is 1 over 4, negative 1 over 4. Okay, alright. Okay, here is the equations. Okay, okay, let's move on to uh, our topics today. So I will start with uh, lines equations with the slope of a line. Okay? So line uh, is basically combination of a point. Okay? So if you connect two points, you can make a line from A to B. Let's say that like that. Okay. And how steep the line is, we call the slope. Okay. So the slope, we can say the slope is like how 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 is the slope is increasing, like it's increasing because the angle is increasing. This is one. And the slope, you can look at uh, this idea here. This is the slope. Okay, if you look in the uh, overview, have a line from the red line here. It has several points that you can see, and look at A and B. Okay, A and B here. It has x1, y1, x2, y2, and slope is defined by rise over run, which is the delta of y over delta of x. Okay, so you can also say this is basically, generally you can say delta y over delta x. And then you see another point, a prime, b prime. This is to compare with the a and b. And it's perfectly the same triangle. So you have the same slope, actually, the same slope, okay? The same delta x, the same ratio of delta y over delta x, okay? And depends on how the slope will be, like the number of the slope, or how the slope will be in the graph. We can say that it's actually positive slope, the first one here, and then it's negative slope, okay? It's zero slope, the gradient is zero, the slope is zero, and there is no slope here, okay? And this is important to understand all of this slope, because it will be used for explaining how the derivative will be in a graph. Okay? How we can understand the derivative from the limit, and we can understand that by looking at the slope of the curve. Okay, okay, that's the slope of a line, and this is the general equations. Okay? Attendance. Okay. Okay, I hope you have scanned. Okay. Okay. Let me give you these two general equation here. The first one is, I think, uh, very basic equation of line. This means that equation of line that has slope m and the intercept y-intercept b. Okay? So we can find m from the delta of y over delta of x. And the second equation is for equation of line that pass through a point. Point is x1, y1, and has slope, same slope. Okay. I think this will be used for, I think, for the whole semester and for the next semester also. We still are going to see this equation of line. Okay? So I hope you still remember how to find the line equations. And of course, you can also rewrite the equations and say that, okay, I can see that this is also a line equation uh, where a, b not both zero. So every line is basically a graph of a linear equation. Okay, then that's quite understandable from this example here. Okay, next thing about lines are, we will have something called parallel and perpendicular. Okay? And it is also appear in calculus. So what does it mean? So parallel lines is right here. This is two non-vertical lines. Okay. Let me write are parallel if and only if they have the same slope. Okay, same slope means it's m1 equal m2. If there's two lines, then the first line have the same slope as the second line. Okay, perpendicular, or let me, if I draw the line, maybe it's like, okay, same 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 slope. Okay, okay. You can see that it's the same tangent, right? The same tangent. Okay. Now you have the perpendicular lines. So when you write two lines with slope m1 and m2 are, are perpendicular. If, okay, and only if m1 multiplied by m2 is 34. That is their reciprocals, or you can also write you can write, or you can draw these, the m1 and m2 maybe like this. Okay. So perpendicular means that they have, let's say this is the m1, this is m2. So this is 90 degrees. Okay, I think that is for general review of line equation. Yeah. Okay, any questions about line equations? I think line equation is not too complicated, right? Okay, let's move on. Let's move on. Let me move to a new chapter, a function. So the chapter before, it's chapter one, all the fundamentals, numbers, solving algebra equations, the simple equations, a line equation, circle. There's chapter one. It's called the fundamentals. Now chapter two is the general topics is about functions. Okay, so let's start a function here, and let me rewrite. Maybe in calculus, I've already telling you the explanation, but let me just give you a small review. So a function is a rule that assign each element x in a set A exactly one element is called f of x in set B. Okay. You can also look at the imagine that this is a function. This is x. This is f of x. This is f. Input and output. Okay. So f is like rule process machine, like something when you put inside, they will have another set going out, which brings still brings the original element x. Okay. Okay. For example, if you are looking at the arrow diagram, this is A, this is B. It's set A and set B, right? And you have maybe this is 1, 2, 3, 4. Maybe this is 20, 30, 40. This is just a random function, okay? And random f of x, a random x. If I have arrow there, and then this is also arrow here, arrow here, arrow here. And I have another set A and B. Okay, so I have two conditions, okay? The first condition here and second condition here. Okay, to test how many of you are understand the function. Which one is the function? Number 1 or number 2? Okay, number 1 or number 2? Which one is the functions? Okay, number 1 or number 2? Which one is the functions? You can type in 1 or 2. Mm-hmm. Okay. So Maria, you choose 1. Jordan, you choose 2. Okay. Okay, anyone else? Okay, Scarlett 1. Mm-hmm. Okay, let me review this. Okay. Number 1, number 2. The difference is, okay, the difference is in A for option 1, you have element 1, element 2. They both go to 20, and that's still okay. But number 2 here, they have element x of 2 is going to 20 and 30, which means can 20. So can it be happening here? No, right? We still can see that this may be true. This may be true. This may be true. Like for example, you have the x squared. You have the same element, right? The same f of x, but different x, right? Still can happen, right? But here, it's logically impossible for our functions to be like this. Okay, so function is number one. Okay. Oh crap. Uh, Let me give you another one. Uh, it's called net change. Okay. It's actually just evaluating that value or value of a function as the inputs changes from A to B, where A is less equal B. We can write this is the net change. I think this is pretty standard, not really a big deal. All right. Um, which I already prepared here. Let me just uh, move to next page for the domain of the function. So domain, let me move here. So let me write the domain is set of all inputs for the function. And domain may be stated explicitly. For example, you have a function x squared, and you have restrictions that x is only from 0 to 5. This is already a domain that is stated in the functions. Okay? So the domain is set of all real numbers, real number x, which, all right. But okay, if the function is given by algebraic expression, which means it has the formula, and domain is not stated explicitly, then the domain of a function or domain of a function is domain of the algebraic expression. That is the set of all real numbers for which expression is defined as a real number. Okay. So we can state the domain explicitly, like we can restrict which the domain will be. But if it's not stated explicitly, we need to find uh, which domain the function has. Okay. Like, for example, look at the function f and function g. Okay, look at these two functions here. The function f, okay, is not defined at x equals 4, right? Because it will be 1 over 0, right? So function so we can say the domain is okay. Or if you want to write completely, you can write x is element real. So meaning the x is all real numbers except 4. You can also write like that. Or you can just write d is x not 4, and of course the other number is okay. You can also write a simple like that. And for g, so function g, it has a square root. Okay. Let me write here. 1 over 0 is undefined. So function g is not defined for negative x. Or you can say it's a complex if negative. But let's just say it's not defined. Okay? It's not defined as a real number. Okay? So domain will be right x greater equals 0, because you can also have it. You can have 0 as x. Okay, it's still okay. Or you can just simply write x. That's still okay too. Okay, any questions? Let me give you several examples of how to find domain. Okay. Okay, let me find domains of functions. Monday, you mean next week, right? Yeah. Yeah, I will announce on maybe on Friday. I will announce, yeah, because it's a national day in Taiwan. Find domains of function. First one is second one is third one is okay. You have three questions A, B, C. I'm giving you maybe around 5 minutes to try. Okay. So about the first one, what is the domain? Okay. How about number A? 1 over x squared minus x. Okay, let me give you example for A. Okay, so you can write this in terms of, you can factorize the x, and then you can write this, right? The same thing. Now, from here, you can see that if we put x equals 0, it will be undefined, right? Or x equal 1, also, it's undefined. So we can write here the domain will be x x not equal 0, x not equal 1. Or we can write the domain in interval notation. Yeah, we can also write this. Okay. And how about this one? This one, it's similar to what we have done before, the square root. We need to have 9 minus x squared need to be greater or equal 0. And then you need to solve this inequality. Okay. Um, if you maybe don't really know what to do, you can just make it in terms of equal sign, and you will get that this will be plus minus 3, right? And you can solve by the line number. And then you need to look for um, the positive value, okay, which is, I think, it's this here. So domain will be or you can write in terms of the interval like that directly. Okay. Last one. Anyone done? The last number? Oh yeah, correct. Scarlett, correct. Yeah. So last one here, x plus 1 need to be greater to 0, right? Because so first, okay, let me write here. If you have this, then you need to have this, right? But when you have this, 1 over square root, you cannot also equaling this with 0, right? So this will be x should be greater than 0. Okay, that means in our case here, our x plus 1 need to be greater than 0, or x need to be greater than negative 1. Okay, so the domain will be or you can write the interval. Okay, I think that's just the example. Okay, let me move a little bit. Still about functions. Okay. Uh, um, it's called the graph of function. If f is a function with certain domain, let's say domain A, then the graph of f is the set of ordered pairs. We can write that in terms of x and f of x. So this is a point coordinate, and x is element A. Okay. They are plotted in coordinate plane. In other words, that the graph f is set of all points of x, y such that y is equal f of x. Okay. So that we can also write down that f is graph of equation y equal f of x. Okay. Okay, this is uh, I think this is a very basic concept of a function. Sometimes you forget that uh, because we already know and we already mentioned many times that y is equal f of x, y is equal f of x. So sometimes you forget that when you have a function, just random functions like that, um, you need to define first that this is y equal f of x. Okay, and then okay, that's the function. Because if you don't define at the very beginning of the process, you will be mixed with just a regular equation, with just regular formula, algebraic expressions, without mentioning that this is a function. Okay, that's in a concept that's different. Okay, but you need to remember that every time we mention a functions, that means you already mentioned that okay, the function has maybe an algebraic formula or expressions that already mentioned in the case, and then okay, that's the function. Sometimes the questions is keep as simple as possible. So it's not mentioning y equal f of x anymore, and it's just directly approach the questions, and it is expected that the students already understand about the functions. Okay. Okay. All right. I think several point here like power functions. You're already familiar with. Okay. We have for uh, to begin with, we have the even function. We have odd function. Usually this is for x squared, x4, etc. And odd functions start from x cubed, x with 5, x7, etc. And you uh, already know at least how the graphs looks like. The difference is when the power is increasing, the graph is it's like a flatten. So let me give you an overview for this one. For example, this is x squared, okay? And then when you have more power, x4, and then more and more power, this is just illustration. But what you are looking at is something similar with this. So it's from this and making it more and more flattened, not really a curve, like a curvy line anymore. It's become flattened. You can check with GeoGebra if you want. Okay, maybe a little bit more power functions, and then I think you already also know from the calculus part the piecewise defined function. So you will have, for example, you have two functions or two algebraic expression as a function. Okay, and also the absolute value function. Absolute value functions and a greatest integer function. This is f of x, and this is the greatest integer. Okay, I think I will explain this next week for the absolute value and the greatest integer. Okay, so now as usual, please prepare, I think, pen and paper and also the smartphone for scanning the QR code for feedback time. So this will be our feedback time. I think it's better if you have pen and paper along with you. Yeah, and check that out. Let me present the other screen. Still have the same QR code. Wait for a moment. Okay. Okay, please. I will be waiting for a while. Okay. I hope you have joined. Okay, let's start. Let's start the feedback time. Okay. All right. Okay. Let's start. Uh, okay. Ready. Okay. It's, on the 20, 15, 14, 13. Okay. 9, 8, 7, 6. Okay. Everyone's voted. All right. Okay. It's perpendicular. Okay. It's pretty much, if you multiply the slope, it will be negative 1. Okay. Okay. Next question. Okay. Let's see who's the fastest. Okay. Good. Good, Jonathan. Good job. Okay. Let's do the second question. Get ready. All right. Okay. Find the domain. Which one is the domain? 30 seconds around. Three, two, one. All right. Everyone has voted. Whoa. Okay. It's D. Okay. Let's see. Oh, okay, Scarlett, congratulations. You win again. So yeah, I think that's it for today. If you need the explanation for the quiz, next week I will explain it to you, and I think I will give you some assignment for the basic of math. Not really that much, but I hope it can help you to understand more of the, uh, especially the inequality and domain. Okay? Because I saw that yeah, it's a short time, but I hope uh, you can get better results. Okay. Okay. So yeah, I think for the assignment I will announce on the Google Classroom, but I will make some reminder on Moodle. But the details in the Google Classroom, and you need to submit to Google Classroom. Also. Okay. Thank you, and you can leave the Google Meet link.